Hello everyone, in this video I am going to discuss resistors in parallel. Okay, so resistors in parallel combination. Okay, this is a resistors are said to be connected in parallel when there is a two common end. In the series we learnt a end to end connection, yes or no? Here you can see one end of this resistor is connected to A. Here you can see resistors R1 one end is at A, resistors R2 one end is at A, resistors R3 one end is at A, and other end is also connected to other common point. Okay, let's say this is point B. Yes or no? Such type of connections are called as parallel connection. So you see, when resistors are connected between two common points, then what happens? The main current in the circuit is divided. So whatever the current is I is passing through it, so it will divide I as I1. Okay, current through R1 is I1, current through R2 is I2, and current through R3 is I3. So main current divides. Okay, na? And you can do it by Kirchhoff's current law also, KCL. You apply KCL. Okay, apply KCL at junction A. This is junction A. What is that? Sum of all the current is equal to, entering current is equal to sum of leaving current. So what is entering current here? I is equal to what? Leaving current, that is I1 plus I2 plus I3. Yes or no? Let's take this equation 1. Now if you see, one end of R1 is at A, other end is at V. Okay, one end of R2 is A, other end is B. One end of R3 is A, other end is B. Similarly, one end of this cell is what? A, other end is B. So potential difference is same in parallel combination. Okay, so what we can write? V1 is equal to V2 is equal to V3 is equal to V. Why? Because whenever I1 passes through R1, there is a potential drop across this right now, that is V1. Similarly, whenever I2 passes through R2, there is a V2. Okay, whenever I3 passes through R3, that is what? V3 is there. But as there is a common end points right now, so potential difference is same. So you can see here also, when the resistors are connected between the two common points, then main current in the circuit divides. Okay, is divided, and the potential difference across each resistors remains same. Is it clear? So what we learned so far? Okay, I is equal to what? I1 plus I2 plus I3. Okay, let's take this is equation 1. Equation 1. Now, what is the current through R1? Can we get? What is the current through resistor R1? That is I1. I1 is equal to what? What we can write? V1 by R1 according to the Ohm's law. But V1 is equal to what? V1 is equal to V. So can we write V by R1? Similarly, what is the current through R2? Current through R2 is what? That is I2. I2 we can write V2 by R2, or V2 is nothing but V. So V by R2. Similarly, we can write current through R3, that is I3. I3 is equal to what? V3 by R3. So or we can write V by R3. Yes or no? Correct na? Now what we are going to do? We are going to take a equivalent resistor, okay, RP, connected to the same source, okay, of V volt. Okay. So what is the current through RP? Okay. So we can write current through RP. That is I is equal to what? V by RP according to the Ohm's law. Let's say equation D. Okay, these equations you can consider this as A, B, C, D, A, B, C, and this was equation 1 only, you have to keep it in mind. Okay, this is D. So we have to use using equation A, B, C, D in equation 1. In equation 1. So what is equation 1? I is equal to what? I1 plus I2 plus I3. What is I? I is nothing but V by RP. So we can write V by RP. What is I1? V by R1. What is I2? V by R2. What is I3? V by R3. Yes or no? Now we can write V by RP. We can take V common. So that is 1 by R1 plus 1 by R2 plus 1 by R3. Yes or no? Now we can cancel VV. So what we can write? 1 by RP is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Is it clear? So what we are getting, the sum of the reciprocal of equivalent resistance is equal to the sum of reciprocal of individual resistances in parallel combination. Yes or no? So if you consider the two resistors which are there in the parallel, okay, if you see here, two resistors are there in parallel. Consider this is a resistor R1, another resistors R2 is there, which is in parallel combination. So directly we can apply the formula. What we can apply? 1 by Rp is equal to what? 1 by R1 plus 1 by R2. So 1 by Rp, you can take a LCM. R1 R2 is the LCM. This LCM divided by R1 will get R2 plus LCM divided by R2. R2 get cancelled, so we'll get R1. So what we are getting? Rp, take the reciprocal, R1. Rp is equal to what? R1 R2 divided by R1 plus R2. Okay, this is for two resistors. Okay, equivalent resistance Rp is equal to R1 into R2 by R1 plus R2. Okay, similarly, if you see, okay, n equal resistors are there in parallel of value R. Okay, similarly such n connections are there. So what we can write? Same 1 by Rp is equal to what? 1 by R plus 1 by R plus 1 by R. How many times? N times. Okay, so what we can write? 1 by Rp is equal to what? N times of 1 by R. Yes or no? Or what we can write? Rp is equal to what? R by N. Yes or no? So what happens actually in parallel combinations, the equivalent resistance is always less than the individual resistance which are connected. I hope you understood these resistors in parallel. Thank you.